You're listening to the Sufficiently Advanced Podcast. Love it. And this is Mr. Halsey.
I'm Hanson.
And we are joined today by a special guest,
Ms.Henderson.
So I guess it's no longer the H squared today. I think we got H cubed.
H cubed.
H cubed.
Hypercube.
Hypercube. We got into the third dimension. We finally made it into the third dimension. So today we're going to be talking about a little bit of a controversial subject, and that is gene manipulation.
Gene manipulation. I like it already.
Yeah. So if you don't know what gene manipulation is, it's where you're able to change the genetics of an organism to fit it however you want. So essentially, if I want to have wings, I could have wings.
Yeah, that sounds amazing. How do we do it? Can I do it now? Because I would very much like to fly.
Yeah, I mean, no. I mean, you
Well,
can
then
build.
forget it. Let's do a new topic.
All right, cool. So we want to talk about a new process called Crispr. Some of you guys
So,
may have
the
heard of it.
refrigerator thing?
Yeah, it's found in your refrigerator. Actually, it is found in your refrigerator.
Is it?
It really is found in your refrigerator.
Okay.
So CRISPR-Cas9 is a protein basically made by E. coli.
I mean, that's
That's
bacteria.
in your
That's
bacteria.
bad.
That's bacteria that's in your refrigerator.
Okay.
And so in the 80s and 90s, they found this. Basically, what they saw, they were looking at the DNA of E. coli, and what they'd see is a repeating pattern followed by something very strange, and then a repeating pattern and followed by something very strange in the DNA sequence. So,
Okay.
So that's interesting.
It is.
Yeah.
So,
Yeah, and she chimes in.
yeah,
I know.
there she is.
Took me a while there.
But so it had this repeating pattern, and they couldn't figure out what it was at all until they started looking at it more closely, and they noticed that there are these like the little intermissions, the little breaks, were actually the DNA of viruses.
Huh. So there's a viral DNA inside the normal DNA?
Yeah.
Huh. That's
And
crazy.
Basically, it is a bacteria's immune system. It works just like our immune system works.
Whoa, okay, so, yeah. Okay, keep going.
I was going to say.
So, all right. So, basically, when our immune system wants to get rid of something, it sends out the white blood cells.
Yeah.
And the phagocytes and things like that attack whatever it is, whatever virus it is.
Yep.
Now, if it's an unknown virus, we're not immune to it. We don't know the properties of that virus. We're more likely to get sick.
Right.
Correct?
Can't fight it off.
Can't fight it off as well. Well, if we've encountered it before, our cells keep a memory of that virus. It consumes it and keeps a copy of its DNA. And so, essentially, that's what CRISPR is doing.
It keeps like a leftover code
Yeah.
to be able to recognize it.
Yeah. And
So why do we care? Why does that matter?
Well, besides the fact that it's just stupid cool and
Yeah.
you're lame for not knowing. But so with the reason that we want to talk about CRISPR is because instead of using it as a defense, scientists have switched it around to be an offense.
Okay.
So essentially,
It's the best defense after all.
yes. So Hanson, what color eyes do you have?
That's a hard question to answer because my eyes change color depending on what I'm wearing.
Why didn't you just say dreamy? That would have been much more funny.
They look pretty
Touche.
green right now.
Well, there you go. Green
I'll
right
go
now.
with that.
So
We'll go with
let's
green.
call them green. Now I have blue eyes.
Okay.
Now, Ms. Henderson, you have what color?
I would say hazel. Mine change too, depending. They go hazel and brown, so I like to call them hazel chestnut.
Oh, okay.
Yeah,
So
get
mine
fancy
are,
with it.
Mine are blue or yellow whenever I'm possessed. So
Mine go red. How weird.
it's amazing. But so let's imagine we wanted to switch eye colors.
Okay, well, we have
We've-
to take out our eyes and put them in your sockets and vice versa?
No. This could actually be accomplished through an injection of CRISPR-Cas9. And would go in and cut out or turn off different genes inside of your eyes and essentially change the color.
Is this painful? You're saying a lot of words like inject and cut, and that sounds
No.
awful.
It does sound awful, but it's actually non-painful.
So you're saying if I decided I wanted to have blue eyes tomorrow, I could go and do this?
Pretty much. Now, before CRISPR, the biggest thing, how much do you guys think a process like that would cost?
Thousands of dollars.
That's like Kardashian money,
Right?
you know? You think it's Kardashian money. But the thing with CRISPR, before we discovered CRISPR, a single gene therapy, like one use of a gene therapy, was $5,000.
Wow.
And that really limited a lot of people in how they could actually use these advancements in medicine.
Okay.
But CRISPR, take a guess. Just take a guess.
Well, you said 5,000, so obviously it's less than that. I would guess 1,000.
You think 1,000?
Yeah, I'd probably say a couple thousand, probably 3.
How about $75?
No way.
Absolutely, $75. It costs about $75
I would not
to
have
run a
thought that.
CRISPR sequence.
Wow.
Holy cow.
So
okay.
what this means is that this is something that we can use for average people. And so, but there's one problem. We're changing DNA.
Yeah.
Now, essentially, this
dicey
could
probably.
Dicey problem, literally. So, what the biggest problem is if we're changing the DNA of somebody, it is individual, because all of our DNA is different.
Different.
Right.
Yeah.
But so it's all individual. So what that means is if someone's already, like our age, teacher age, we're just going to say teacher age, because that it's not inherited.
Right.
So do you want to tell us a little bit about inherited traits versus acquired traits?
Versus acquired traits. Okay, so inherited traits are going to be essentially what you get from your parents. So you will have, that's why you look like your parents. You'll have similar hair color and similar eye color. For instance, my daughter, all my friends tell me that she got my ears, and that's about it. She looks exactly like my husband, looks nothing like me. That is an inherited trait. An acquired trait is going to be something that is learned. Like you learn how to ride your bike, you learn how to wash your hands, things like that.
So essentially like my giant thug life tattoo.
Yes, exactly.
For
That
those
is an acquired trait,
that's
for sure.
For those that don't know, I have thug life tattooed across my chest.
It's true. Can confirm.
Yeah, y'all don't know me. So, yeah. So that can't be passed down. My kids didn't come out of the womb with thug life tattooed across their chest. That's something they have to earn. So the problem is that these are non-inheritable traits. So if we are removing genes that cause cancer, those would still be passed down. But they could simply be changed by a simple injection later on in a child's life.
So we haven't really mentioned it before, but this is like one of the big deals. It's not just about eye color. It's about recognizing and pinpointing genes for serious diseases that we can literally cut out of the genes in the DNA that can prevent people from even getting those diseases. I mean, that's huge. And for something like $75 to keep somebody from having a serious genetic disease is unreal. And in the medical community, it's unheard of. Any new therapy starts in the 50s to 100,000s and slowly works its way down as it's used more and more. So this is crazy.
Yeah, and it started off cheap. That's the big thing.
Right.
Now, that brings up a good point that I wanted to talk about. So we kind of understand what CRISPR is. It can cut out bad genes and put in good ones.
Yep.
Right? Great. Where's the ethical line?
That sounds like a long podcast question.
It happens to be a long podcast, so
There
let's
you
talk
go.
about a long podcast question. That's one of the biggest things when it comes to genetic engineering.
Yeah.
Where is the ethical line?
Sure.
When are we actually saying that, okay, we can change all the humans. We can actually, like, let's say the idea is with CRISPR, if we get early enough during incubation, that we could completely change the DNA code, and that then would be inheritable.
Huh. Okay.
And so we could actually make like a race of super babies with like telekinesis and not really telekinesis, but they could set you on fire if you don't bring them their pacifier fast enough.
So I guess the argument is mostly how much is still allowing nature to take its course, and how much is it okay for us to, do what we want, and how much can we change? So my opinion on it is pretty loose. I feel like the better we can give ourselves advantages as a human race, the better it's going to be for us. Whereas when you encounter things like income disparity, that's where I think it breaks down. If it becomes a therapy that only the rich can afford and that they're the only ones who can get it, that's where it becomes a problem. Because then you have this super rich race of superhumans that is just going to blow away all the people who can't afford it and create this massive gap in opportunity and economics that is already too big as it is.
Yeah.
Sounds like a good movie.
Yes, it does.
So what do you
They
think?
have made a few movies like that. Along those lines, thinking about how my daughter looks exactly like my husband, and for those who don't know me, I'm currently pregnant now. If I had the choice, and if it was cheap, to make this daughter look more like me, I would probably do it. But where is the ethical line? If I was able to take certain bad genes out, like cancer runs in my family. If I could take that out, I would love to do that. But like you were saying, if it's more of a money issue, essentially people who have more money are going to be able to achieve things like that. And maybe one day people will want to go through and they're going to want to have the cancer genes removed, and that's something nobody wants a family member to pass away. So I feel like people are going to be fighting for this idea to eliminate all these diseases, but then it could also cause an overpopulation issue. So there's always theories like that, like where they say like the government is hiding the cure for cancer because
Illuminati.
It's creating that, essentially eliminating people from the population. So that's what diseases do.
Now, speaking of eliminating things from populations for population control, what if could that not lead to the removal of undesirable organisms, including humans? So it's like
Cockroach. Wish you could do
Careful.
cockroaches one day.
Oh, please.
Well, I mean, think about something we
Ideal.
deal with really, really a lot here in Texas, and they've been horrible for the last couple of days, or actually the last couple of weeks. Mosquitoes.
There it is.
They're horrible.
The bane of our existence. Ugh.
I must give off some sort of scent because I walk out of the house and I have like 10 mosquito bites all over me.
Yeah, I'm one of those people who I hang out outside with my friends, and they're like, I'm not getting bit at all.
Yeah.
And I'm like covered in mosquitoes. It's the worst.
What's your blood type?
I don't know.
Oh, well, you should know that in case you ever do
Yeah,
go to the
I
hospital.
would like to, but when the last time I gave blood, I passed out and had a mini seizure. So I don't give blood.
Yeah? Well, that's...
It's a little too scary.
I've passed out too from giving blood, ironically. So there's that.
So I'm O positive. And their studies show that people like O positive blood actually, some blood types actually attract mosquitoes. So like I know
heard that too.
both my kids are O positive too, and they get bitten and they swell up like little. Anyway, but
Okay, so we hate mosquitoes.
we hate mosquitoes. Mosquitoes.
Crispr.
Okay, so let's say we were able to manipulate the genes that determined the sex of an organism.
Okay, I'm following.
Okay, so we we genetically manipulate a population of mosquitoes, like those that have been plaguing us with malaria and Zika and West Nile for years and years and years, and making people sick and die, and it's not great. And so let's say we manipulate those genes to where they're only male. Like manipulate to where they only produce male offspring.
Then they
Okay.
wouldn't be able to reproduce
They wouldn't be able to reproduce.
And then,
and pass on those genes to their offspring and affect humans.
And that sounds great.
that sounds
It does
amazing.
sound
I would
amazing.
love a mosquito-free world.
Yes, please.
Of course, there's always consequences, though.
Really? Like what?
For instance, if you eliminate a specific species, you're never entirely sure as to what could happen because they all species, they play a role in our ecosystem. Whether it's good or bad, or for instance, cockroaches, I seem to have no idea why they're even on this planet, for instance. But
To
everything
make me
plays
scream like a little girl. That's what they're for.
everything plays some sort of role, and so if you take out a certain species or a certain organism, you never know what's going to happen and how it's going to affect those that maybe consume it or use it for some sort of benefit or something like
Like
that.
my favorite mosquito-eating organism, bats.
Yes.
I love bats.
I mean, this comes into all the way back to the ethical part. It's like in the third world, one of the most common causes of death is malaria, which is from mosquitoes, and especially infant death. So how do you weigh that? The potential risk of messing up an ecosystem compared to eliminating a major cause of death in poor populations. Like, that's an important thing to weigh. There's some big cost benefit analysis there that needs to happen.
Yeah, I mean, and when does it become, if we continue with this, like manipulating genes, when does it become a point where it's fashion?
Yeah.
Like, look at me, I got tiger claws.
Well, another crazy thing is, what if we get good enough at it that we start diverging our own species?
Or even stop aging.
Please, that's what I'm betting hard on that. My bets are on figuring out biologically how to stop aging, or that we're all in a simulation and I can wake up outside the simulation after I die. Those are my 2
You'll
big
never
bets
wake
for
up.
immortality.
That's
You'll
where
never
overpopulation
wake
comes in, though,
up.
as well.
How dare you?
Never.
How dare you? Don't steal my dreams of immortality.
You know this is being
That's all I
sent
have.
This is being sent to the overlords right now.
Oh my gosh.
Being like sent immediately.
This podcast brought to you by Hypnotoad. I'm sorry, what? Where were we?
Nowhere.
Oh my goodness.
You're regretting.
What did I
hanging
get
it.
myself into here?
So you were talking about overpopulation. You know, it does.
It always comes back to that, yeah.
And so I think that's a good place to kind of end it. You know, that this is a really amazing technology. It has a lot of benefits, but it's one of those new things that we have to say, is it ready?
Yeah.
Is it ready for the wider world?
Open-ended.
And it is. It's very much an open-ended. And since it's open-ended, we want to hear what you have to think. So tell us in the comments below, do you think that this is something amazing that we should embrace open-heartedly? Or do you think that there are some big issues that might come about with this? So once again, thank you for listening to the Sufficiently Advanced podcast. I'm Halsey.
I'm Hanson.
And I'm Ms. Henderson. Thanks for having me, guys.
All right. Later.